b cannot be 0, or it cannot be 1, and it has to be bigger than 0. So if base b to the x equals b to the y, it's simply the exponents have to equal each other. So x has to equal y. And similarly, we're talking about bases with the same, or logs with the same base. So if you have logs with the same base, then what you're taking the base of, or the log of, have to be equal. So x, again, has to equal y. So for number 1, again, this is that first property. We have a base of 2 here on the left and a base of 2 on the right. So that means that our exponents have to be equal to each other. So we're going to make an equation. So x minus 2 equals 4x minus 4. They're the exponents. We're going to go ahead and solve this for x. So we end up with, let's see, 2 equals 3x. So your x value is 2/3. Let me put a box around that. In number 2, we run into a little snag here because we have a base of 3 and we have a base of 9. Well, they're not equal, so we can't just say that the exponents are equal. So what we have to do is we want to convert the higher base and bring it down to a lower base. So again, we're going to take the 9, and instead of setting the exponents equal, we're going to rewrite the number 9 as 3 to the second. So I'm transferring, just redoing that so that instead of 9, I'm making it 3 squared. I'm going to carry down that exponent. And then I'm going to keep on the left-hand side, the base of 3 and the 3x minus 6. So now if we take a look, both sides now have a base of 3. So remember that when we set the exponents equal, I'm going to have to distribute the 2 here as an exponent. They do multiply. So you'll have 3x minus 6 on the left, that's the exponent, and on the right it'll be 2x minus 4. We're going to solve this so we get x equals 2 as our value for x. The one on the right, or number 3, we have a base of 4 and a base of 8. There's no way that you can take the number 8 and break it down. It's not 4 to some power. Same thing. You don't want to just multiply 4 by 2, so that's a common mistake that people make. They want to multiply 4 by 2, but order of operations says you have to take care of exponents before multiplication. So you can't make that bad math mistake by multiplying first. So what we do in this case is we just break both of them down so that they have the same base. So for example, 4 can be rewritten as 2 squared. And then we carry down that exponent to the 3x. And then 8 is 2 to the third. Carry down the exponent that was there. Remember, we multiply exponents now that the bases are the same. So 2 times 3x is 6x. And on the right, 3x plus 3. Again, I got that by distributing the 3 to the x and the 1. And then we solve, you get 3x equals 3, so your x value is 1. For number 4, this is similar to the other problems, except we have a log and they're both base 10 on either side. So that means that we can set x plus 5 equal to 2x minus 3. Again, we can do that because on both sides we have a log with the same base. So if we solve this one, we get x equals 8. For number 5, pretty similar. They both have a log base 10, so it'll be x squared equals 2x minus 1. Now this one is quadratic, so we're going to go ahead and subtract everything over, add the 1. So we have it set equal to 0, so we can factor it or use your quadratic formula. So you have x squared minus 2x plus 1. And this one is factorable. X minus 1 and x minus 1. So we have an x value of 1. So one thing we want to just double check is, remember, we can't have a log that's 0 or negative. So I'm going to go back to number 4 and just double check. So I'm going to plug in the 8. 8 plus 5, well, that's not 0 or a negative number. Same thing over here, so you have 16 minus 3 is 13, so that's okay. Just double check in number 5, plugging the 1 in. 1 squared is 1. That works out. And then plugging in 1 in over here. 2 times 1 minus 1 works out for us also. Alright, so we get a little bit tricky in number 6. We can't just say x plus 5 equals 2, because on the right-hand side, the 2 doesn't have a log with it. So what we're going to do is we're going to, when in doubt, rewrite it as an exponential. So if you can't solve it the way it is, try rewriting it and see what happens. So the base in number 6 is 10. So this would be 10 to the second equals x plus 5. That's how we rewrite it as an exponential. Well, 10 to the second is 100. X plus 5. And then subtract your x, or subtract your 5, you get 95 for an x value. Again, just double check. If you plug that back in, you end up with 100. That's not a problem. So for number 7, we notice that we do have logs on both sides, but here you have a plus sign in the middle. So we're going to have to use some properties of logs that you've learned before in a previous lesson. So the first thing I want to do is I have a coefficient of this log. So I'm going to rewrite that as log x squared plus log 2 equals log 8. And then again, the next property is we're going to use the product property that tells us, since there's an addition, I'm going to condense them into a single log. And remember, if it's an addition, we're going to multiply what we're taking the logs of. So I'm going to multiply 2 times x squared. It would just be 2x squared equals log of 8. And now, lucky for us, we now have, on the left we have a log that's base 10. On the right we have a log that's base 10. So I can go ahead and set 2x squared equal to 8. So 2x squared equals 8, x squared equals 4, so x is 2 or negative 2. Now keep in mind that we have to just double check, so if you plug a 2 in inside this log, you're just going to get 2. That's okay, because remember, we're just looking to see if we get a 0 or a negative number. If we do, then we cross it off. It's not allowed. So 2 works. So we'll go ahead and circle that. And then check negative 2. Uh-oh. If you plug a negative 2 in there, you can't take the log of a negative number, so that one we throw out. It is what we call an extraneous solution. For number 8, 3 to the x equals 4. This one we have no properties of logs, so we're going to have to use the change of base formula, which we just learned in the last lesson. So the first thing I notice is that 3 to some power is not going to give me 4. I cannot rewrite 4 as a base of 3. So I can't say 3 to some power and get 4 unless it's going to be a decimal and you're going to estimate. So what we do is we take this exponential and we're going to rewrite it as a logarithm. So this would be log base 3 of 4 is equal to x, just as we've been rewriting them all along. So again, just to kind of give you an update, the base here is 3, so that's the base of the log, and then it'll be 3 to the 4th is equal to x. And now it's simply just the change of base formula, so it will be the log of 4 divided by the log of 3, and that will equal your x value. So when you type this into the calculator, you should get approximately 1.262 for your final answer. Make sure that you try to type it in the calculator, and if you're having problems figuring out the calculator, please let me know. Number 9, pretty similar. Again, we can't rewrite either 5 or 6 as a base of the other, so we're going to rewrite it as a log. So it would be a log base 5 of 6 is equal to x plus 1. On the left side here, we're going to rewrite that as a change of base. So it would be log of 6 divided by log of 5. And then that will equal your x plus 1. And then we're going to have to subtract 1 to isolate the x. So it'll be log 6 divided by log of 5. And then we'll subtract 1 in our calculator. And that will give us our x value. And when you type that in your calculator, you should get 0.113. Go ahead and try number 10. Number 10 is similar to numbers 8 and 9, so you should be able to follow the format that we've done there. So for number 10, you'll see my work here on the left, and my final answer to number 10 was x equals, well, approximately equals 7.585. Number 11 again is pretty similar to what we've been working on. It's maybe a few more steps to finish up, but you start the same exact way. So we're going to rewrite it as log base 2 of 11 is equal to 2x minus 5. I'm going to use the change of base formula. So log of 11 divided by log of 2 is equal to 2x minus 5. Now for this one, to isolate x to solve it, I'm going to add 5 and then divide by 2. So log 11 divided by log of 2. I'm going to add 5. Now it looks like a complex fraction if I say divide by 2. That's what you're going to do in the calculator. Just to write it down, I'm going to write multiply by 1/2. Remember, multiplying by 1/2 is the same as dividing by 2. However, it looks a little nicer having it multiplied by 1/2. So our final answer, once you type this into your calculator, should be 4.230. For this last problem, we have to isolate e to the x squared. So we have to divide by 4 will be our starting point. So when you divide both sides by 4, you get e to the x squared is equal to 16, because 64 divided by 16 is, or 64 divided by 4 is 16. So now I'm going to rewrite this as a logarithm. So this would be just like you did the other problems. Log base e of 16 is equal to x squared. Now you may notice that here we have a log base e, and you hopefully remember that log base e is simply the natural log. And then we're going to carry down the 16 is equal to x squared. Now the natural log of 16 you can just type into the calculator, and then that gives you a number, and you're going to take the square root. Now remember, you have to remember plus or minus, so you have x equals plus or minus the square root of natural log of 16. So when you type that into your calculator, you get x equals plus or minus 1.665. For number 13, we're going to have to go ahead and use properties of logs. Now on the right side here, now the property that says that you can set, if you have a log, some base of something equals a log base, the same base of something, you could set them equal. So that property that we did in the beginning of the lesson doesn't apply here because you have the plus sign. So we have to somehow eliminate that plus sign. So we're going to use properties of logs. So if you have an addition sign, we're going to use our product property. So on the left side, I'm just going to keep it the same. And on the right side, I'm going to condense those two logs into one. And when you have addition, you're going to multiply x times x minus 2. And I'm just going to go ahead and do that. X times x minus 2 is x squared minus 2x. Now that allows us to use that property where we have a log base 4 equals a log base 4. You can set both of these equal to each other. So we have 2x minus 3 is equal to x squared minus 2x. Here we have a quadratic, so we have to solve the quadratic by setting it equal to 0. So I'm going to take the 2x from the left and subtract it to the other side. So we'll have a minus 2x, and then I'm subtracting 2x, so that's minus 4x. And I'm going to take the minus 3 and add it to the right side. This one is factorable, so we'd have x minus 3 and x minus 1 when you factor it. And then using your zero product property, you can solve x equals 3 and x equals 1. Now before we put a box around them and say this is our final answer, you just have to make sure that they're not extraneous. You get extraneous solutions if you get a negative inside of a log. So you can't take if this number turns out to be negative or 0, then it's extraneous, it won't work. So I'm going to take the number 3 and plug it in. 2 times 3 is 6, 6 minus 3 is 3. So that's good. Plug a 3 in here, that works. Plug a 3 in, 3 minus 2 is 1. Perfect. So 3, we could put a box around. The number 1, let's plug 1 in. 2 times 1 is 2. 2 minus 3 is negative 1. And that number inside of here can't be a negative. So that means that the number 1 is extraneous, meaning it's a solution that we generated but makes the original problem not correct. So the final answer would just be x equals 3. Number 14. Again, we're going to use properties of logs and condense my left side. So you have log base 3, and it's subtraction, so that means you're going to use division, that quotient property. So you'll do 9x divided by x minus 8 equals 4. Now here's the problem. We can't take 9x divided by x minus 8 and set it equal to 4 because the 4 doesn't have a log with it. So at this point you're kind of stuck. So when you feel that you're stuck, you should stop and rewrite the problem in another form. So right now we're in log. So I'm going to rewrite this as an exponential function. So 3 to the 4th power is equal to 9x divided by x minus 8. Now we're going to cross multiply. 3 to the 4th, let me evaluate that first, is 81. Remember that's 81 over 1. Cross multiply, so you'll have 81 times x minus 8. And then 1 times 9 is 9x. Distribute the 81. 81x minus 648 is equal to 9x. And then after that, I'm going to have to take, I'm going to add 648 and subtract 9x. So I'm going to move that over and move that over. So you'll have 81x minus 9x equals 648. So 81 minus 9 is 72. And then I'll divide 648. I'm going to divide that by 72. And you get x equals 9. And just to double check that it's not extraneous, plug the 9 back into the original problem. 9 times 9, that's perfect. That's not 0 or negative. And then 9 minus 8 is okay too. That's just a 1, which is just fine. You can't have negative or 0 where they are extraneous. Let's take a look at number 15. Number 15 looks pretty complex. It's not so bad. So for number 15, the first thing I'm going to do is put a 1 underneath the 4. Because in this problem, you're also going to have to cross multiply. So you're going to multiply 20 times 1, which is just 20. And I'm going to multiply 4 times 1 plus 3e to the x. So let's see, distribute, you get 4 plus 12e to the x. Subtract 4, you get 16 equals 12e to the x. Now our goal here is to figure out what x is, which means that I need to use a logarithm because, well, x is in the exponent. but I also need to get e to the x by itself because you have to get the base by itself. So I'm going to divide both sides by 12. So 12 divided, or 16 divided by 12, they're both divisible by 4, so 4/3 e to the x. And now again you're stuck, you can't solve this exponential, so you stop and you rewrite it. So the base here is e, so it'll be a log with a base of e of 4/3 is equal to x. So I rewrote it from exponential to a logarithmic equation. So now the log base e, you could just rewrite that as the natural log of 4/3. So in your calculator, you're going to find the natural log, and if you're using Desmos, that is also in the functions. So if you go to functions and then miscellaneous, the natural log is in there. You're going to type in the natural log of 4/3, which is approximately 0.288. Or if you rounded to 2 decimal places to the nearest hundredth, it would be 0.29. And number 16. Number 16, you can't really rewrite it at this point. You can't cross multiply. This one is actually a factoring one. It's a trinomial. It's a good problem. So to get e to the 2x, you need an e to the x and e to the x, because remember you add exponents if you are multiplying. So e to the x would be e to the x plus x. X plus x is 2x. And then to multiply to 9 and add to 8, you need 9 and 1. And I need a -9 and a +1. So use your zero product property. So I'll set each of these factors equal to 0. So e to the x minus 9 equals 0. And e to the x plus 1 equals 0. Here on the left I'll add 9. And on the right I'll subtract 1. And then again, in order to solve this exponential, you need to rewrite it as a logarithm. So this would be a log with a base of e of 9 equals x, which is just the natural log of 9, which you can put in your calculator. And over here on the right, it's the log base e of -1 is equal to x, or the natural log of -1 equals x. Now the natural log of 9 you can type in the calculator. So you just type in natural log and then the number 9. And you should get an x value of approximately 2.20 if you round to 2 decimal places, or 2.197 if you go to 3. And then the natural log of -1 is not possible because you can't take the log of a negative number, so that one does not create any solution. So that's number 16. Number 7, or apparently I didn't change my numbering. This should be number, 15, 16. This is 17. And then this one should be 18 and 19. So for number 17, you have $1,000 from a summer job and you put it in a CD, a certificate of deposit, earning 5% compounded continuously. So that means I'm going to use the A equals P e to the RT because it's continuously. How many years will it take for your money to double? So you save $1,000, that's your principal. Let's see, it's 5%, so 0.05. And you're looking for the time it's going to take to double. Well, if you're going to double 1,000 in the end, you want 2,000 because you want it to double. So you're going to divide both sides by 1,000 because we need to get the e alone. So you'll have 2 equals e to the 0.05t. Now we're pretty similar to where we were in the last couple problems. you're going to rewrite this as a logarithm. So it's a log base e, because that's the base of the exponent, of 2 is equal to 0.05 times t. This is just the natural log of 2. And then to figure out the time, you divide both sides by 0.05. So you'll type in the natural log of 2 divided by 0.05. And you should get a time of approximately 13.86 years. Of course, that's probably about 14 years, so you might as well wait till till the 14th year to get it to double. So that's a pretty long time for the money to double. So number 18, if a money is invested in a savings account earning 4% compounded quarterly, so I'm going to have to use my compound interest formula, how many years will it pass until the money triples? So let's see what we have here. I'm going to use the formula. Let me move it over. A equals P 1 plus R divided by N to the N times T. So we're starting with, well, it doesn't tell us how much money to start. It just says if money. So you can really, it doesn't really matter how much it is. You can say your principal is $10. So you're saving $10. For it to triple, it would be 30. Again, it doesn't really matter what this number is. If this number was 100, it would be 300 over here. If this was 1, this would be 3. If this was 3, this would be 9. So you just want it to triple. The division will end up working out to be the same way. 1 plus 0.04 is your interest rate. It's compounded quarterly, so that's 4 to the 4 times t. First thing I'm going to do is divide both sides by 10. That'll eliminate that number up here. So on the left, you have 30 divided by 10, which is 3. And then on the right side, inside this parenthesis, I have just a number that I can figure out in my calculator. So you're going to take your calculator and you're going to type in 1 plus 0.04 divided by 4. When you do that, you should get 1.01, and that's to the 4t. And then, again, you're solving an exponential function, so you can't solve that as it is, so we're going to rewrite it as a logarithm. So it'll be a log with a base of 1.01. Remember, the base of this log is the base of the exponent, so that's how I got the 1.01. Of 3 is equal to 4t. 4t. Now, over here on the left, you can use your change of base formula to evaluate that. It would be log of 3 divided by the log of 1.01. And that would just be in your calculator. Once you get that number, you're going to divide that by 4. So let's see what we get when we do the log of. So make sure you're learning to type this in the calculator, so you're typing it as I am, so that way you're practicing yourself. So log of 3 divided by the log of 1.01, and that gives you approximately 110.41. Now, I don't really care what that number is because I'm just going to hit divide it by 4 in a second. So I'm not going to, this number you don't have to write down because I'm just going to take that number and divide it by 4. So we get approximately 27.6 years. So 27.5 years about will it take for your money to triple. And the last one, $3,000 is invested in a savings account, so that's your principal, compounded semi-annually. How many years will it pass till there's $8,000? So let's see, again, we're going to still use that same formula. the one that we learned back when we did regular compound interest. In the end, we want $8,000. And principal, what we're starting with is $3,000. Interest rate is 0.025. Semi-annually, so that's 2 times a year. And then our exponent is 2 times t. So we're looking for the time again. So first step, divide both sides by 3,000. So you get 8/3. And then when you type in whatever's in this set of parentheses, 1 plus. So right here, I'm just going to put this in my calculator. 1 plus 0.025 divided by 2. And I get 1.0125 to the 2t. And again, now we have our exponential that we need to rewrite. So it'll be a log with a base of 1.0125, 8/3, and that'll equal 2 times t. So when I did my change of base formula here on the left, I ended up with 78.96. Again, it's not so important that I write that exact number down, because once I finish typing in my calculator, I'm just going to hit divided by 2 for my time. So we get approximately 39.48 years. So almost 39.5 years for $3,000 to get to $8,000 at such a small interest rate.